This is problem number 6 on the practice problems for test number 1. Solve each system of equations using your choice of substitution or elimination linear combinations. Part A, 5x minus y equals 2, y equals 2x minus 5. So for me, this problem is more appropriate for substitution because one of the variables is already solved for. It's not to say you couldn't use the elimination method or the linear combinations method, but for me, this one is more naturally a substitution problem. So what does that mean? It means you take the y value in the one equation and you replace it with the y from the other equation. So instead of this y right here, we're going to put what y is equal to in the bottom equation. So I'm copying this first equation here, 5x minus, I'm going to leave some space, equals 2. And the space I've left is for y, should be 5x minus y, but instead of y, we put 2x minus 5. That thing right there is exactly the same as y. But I've made a mistake. The mistake I've made is that the y was supposed to be subtracted. It was supposed to be 5x minus y. And if y is only one term, no problem. But if y is a couple of terms, like the highlighted stuff here, it's a problem. We need parentheses. We are subtracting the entire thing. Okay, so those parentheses distribute. The minus sign distributes. So 5x minus and then 2x plus 5. Combine terms here. 3x plus 5 is 2. Subtract 5. Divide by 3. And we get x is negative 1. And then how do we figure out what the y is equal to? Well, let's go back to the original equation that we substituted. That was y equals 2x minus 5. We just figured out x is negative 1. So we just plug it back in. So y equals negative 2 minus 5. Y is equal to negative 7. So when all is said and done, I guess we just got our two answers here at the bottom. X is negative 1 and y is negative 7. Part B, x minus 5y equals negative 1. 7x minus y equals 10. So you could do either linear combination method, the elimination method here, or you could use substitution. If you want to do substitution, you need to solve one of these equations for one variable. If you want to use elimination, you got to get the coefficients of one variable to be opposite, same number but opposite. So I feel like both of them are probably about the same amount of work here. I'll go ahead and try the elimination method. So I'm going to multiply the top equation by something to try to make it so that the coefficient here and the coefficient here are opposites of each other. So the 7x is fine. I'd really like the top number to be a negative 7x. So let's multiply this equation here by negative 7. So multiply everything in that first equation by negative 7 gives me a negative 7x. Negative 7 times the negative 5 is plus 35y. And then negative 7 times negative 1 is positive 7. And then I'm going to copy the other equation. No need to do anything to it. 7x minus y equals 10. And the nice thing about the way we've set this up here is that if you add these two equations, then something really good happens with the x's. Negative 7x plus 7x cancels. So we'll just add the y's. 34y is equal to 17. And then divide both sides by 34. We get y is 17 over 34, or a half. Okay, so now that we know y, we still have to find x. So we're going to go back and pick either of the two equations that we started with to find x. I think it's easier to take this first equation and copy it up here. X minus 5y equals negative 1. But instead of y, we just figured out that y was a half. And then we can solve this for x pretty easily. X minus 5 halves is negative 1. Add 5 halves to both sides. So you can either go to decimals or you can convert everything into fractions, but however you do it, you should get 3/2 or 1.5. So then our answers for this one, I'll try to write it down here at the bottom. X equals 3/2, Y equals 1/2. And it's probably worth just trying the substitution method for yourselves just to see if it's any shorter or longer or about the same as this one. I'll do it really quickly here. So we're going to want to solve one of those two equations originally for either x or y. I would grab the easiest one. The easiest one that I see is this top one for x because there's no x, nothing in front of the x. Whereas if you solve the bottom equation for x, at some point you'd have to divide by 7, which would be kind of messy. If we solve this top equation for y, you'd have to divide by -5. That's kind of messy. If you solve the bottom equation for y, not that big a deal. You divide by -1. You could handle that. But I'm just going to solve the first equation for x by adding 5y to both sides. And then I'll substitute that into the second equation. Second equation said 7 times x minus y equals 10. What is x equal to? X is equal to -1 plus 5y. I'll distribute the 7. And it's starting to look quite familiar to the way we did the first problem. I'll combine the y's here. -7 plus 34y is equal to 10. Add 7 to both sides. 34y is equal to 17. And that looks really familiar. In fact, that's exactly where we were at this stage of the problem. So we won't finish because finishing here is basically the same. Find y and then substitute in somewhere to find x. Okay, finally part C. 3x plus 4y equals 1. 2x minus 3y is equal to 12. I would not use substitution here because no matter which letter you pick from which equation, you're going to end up having to divide by something. If you want to solve this one for y, you'll end up dividing everything by -3 at some point. And I'm going to avoid the fractions by doing the elimination method. It is a little bit tricky though. We're going to want to try to multiply one equation by some number and another equation by some other number to try to get the coefficients of either x or y to be the same number but opposite. So for example, if I see 3x and 2x, the least common multiple of both of those is 6x. So I could turn them both into 6x, or maybe one +6 and the other one -6. Or if we look at the y's, 4y and -3y, least common multiple of those is 12y. So we could turn one of them into a 12 and the other into -12. I have a slight preference for that one because they already have opposite signs. Whereas if you solve for, if you do the x's, you'll have to multiply something by -1. So let's just go ahead and see if we can multiply both of these guys by the right thing to turn them each into either a 12y or a -12y. So if I want to turn the 4y in the first equation into a 12y, we're just going to multiply by 3. And in the second equation, trying to turn this -3 into a -12, multiply by 4. So let's write what we get. 3 distributes through everything. 9x plus 12y, that 12 is what we were after. 3 times 1 is 3. Second equation, 8x minus 12y, that minus 12 is what we were after, equals 48. And we're going to add these equations. And when we add them, we get 17x. The y's cancel by the way we built it, is equal to 51. Divide both sides by 17. X is equal to 3. Finding y is going to be a little bit of work, no matter what we do. Let's go ahead and take the first equation. You could just as well take the second one. First equation says 3x plus 4y equals 1. But instead of x, we'll put what x is equal to. Turned out x was equal to 3. And now we'll do a tiny bit of algebra to solve for y. Subtract 9. Divide by 4. And then we have our final answer. X was 3, y was -2. For practice, I'd encourage you to try solving the same exact problem again, but instead of multiplying by 3 and 4, which led us to something nice for the y's, multiply by different numbers, try to build something nice for the x's. If you do everything right, it should be about the same amount of difficulty and definitely should end up with the same numbers that are boxed here in red. X should be 3 and y should be -2.